Welcome back to the fifth and last part of my lecture on introducing Kansei Engineering. In the parts before, I've been talking about the need of effective design. I've been explaining what the Kansei is. I've been explaining what Kansei Engineering is. I've gone into a structure on Kansei Engineering. I gave you a little example on how to utilize this, how that's done practically. The fifth part is the very last part where you can lean back and enjoy, because now I will talk about what are other products which have been developed with Kansei Engineering. How has Kansei Engineering been used in those products? And it will just give you the range of different products which can be developed with Kansei Engineering, and those are pretty successful products which are on the market today. So enjoy.
So, final chapter, case studies, real studies. This study before is the fizzy drinking bottle is a real study, but I didn't present all the results because the company owns them. But study with real background, real products, and real results are here with products which you can actually buy on the market. Let's see, we start with the Mazda Miata case. The Mazda Miata case was the very first case of Kansei Engineering applied in car industry already in the 1980s. The thing is that Mazda at that point was not very successful. They built, however, very quality, good cars, but they were considered as boring in some way. So what do you do if you are a manufacturer of that? You have your qualities, you have your products, which are good, but people don't think that they're very exciting. So they realized very early in the process that what's most important here is one cannot see with the eye. So you have an effective aspect, and how can we improve that? And Mazda said that they wanted to have a star. They wanted to have something which really stuck out, something which everybody desired. You can do this in some way, and many car manufacturers do that. They build a very expensive and very nice car. And although, for example, Tesla, they came up with the Roadster initially, and everybody wanted it, but it was too expensive. And then they started production of normal cars when by buying a normal car, a normal Type 3, for example, you get a little bit of that ultra performing sports car as well. But Mazda wanted to go the other way. They wanted to say it must be something affordable, so people would be able to afford this product. And they came up with, yes, we should do some type of sports car. By 1984, when they decided to make that decision, they said they wanted to have something which really stood out for Mazda, and they wanted something which was in some way defining for the car brand. So what to do? And they came up with an idea. In the 1970s, there was a flora of different sports cars in the UK. British sports cars. Everybody who has been watching a James Bond movie knows what I'm talking about. Very edgy, very sporty cars. Unfortunately, very unreliable. And very unreliable cars is something people might buy from their perspective of admiration and enthusiasm, but something in the end, the British sports cars manufacturers went bankrupt because of bad quality, or partly of bad quality. The thing is now that Mazda said, okay, let's combine this British sports car feeling, very raw, very unrefined, but very attractive, with our good quality car, our good quality knowledge. And that's something we want to integrate into one car. They formulated this goal here where they said they wanted to have passion. I mean, read this. Once you're behind the wheel of a Mazda, you can feel the passion that only Mazda through Kansei Engineering can bring into the car. That's kind of revolutionary, right? As an engineer, passion, engineering, does that work together? Yes, it does. We can measure passion now, as you have been understood, if you learned, and we can integrate that into product development. And that is what Mazda did for the first time on the car sector. Nowadays, it's pretty common, but that is what they did the first time in the 1980s. So what are the properties of a car which are the most effective? And I pointed out some of them, but I didn't really point out the most important. So think a little bit. What is the most important feature from an effective perspective into a car? Well, think this way. You have seen that car on a commercial or on the road, and now you decide that could be something for me, and you go into the showroom. What do you do? You go towards the car, you open the door, and that's the first physical contact with the product. The physical contact is a very, very strong Kansei. It's unconscious. You don't know about it. You're not aware of that. But if this car handle does give you the impression of weak, cheap material, within these 0.4 seconds I mentioned before, you will actually get the impression of that's not my product. It's bad. But if it gives you the impression of sturdy, sporty, reliable feeling, yeah, well, then you go on, you get into the car, you feel the seat, you feel the steering wheel, you feel maybe the shift lever or the handbrake or what they give you, the surfaces, the physical surfaces. That's very important. Also smell. But the very first impact, the very first impression is the most important. So also the sound and doors and the feel of the door is very important. Car manufacturers like Mercedes-Benz have been working with that for a long time. They even have a lab only evaluating the clapping sound of the door and the locking noise of the lock, because that's important to the users. Then Mazda went on and did more or less the same thing as we did with this pyramid here. Here the pyramid is turned 90 degrees and top down. This is the general Kansei, and then it's broken down here. The general, oops, this would be the right, I'm sorry, that would be the right slide. The pyramid is broken down here. We're starting with the zero level, the general Kansei, HMU they call it, Human Machine Unit. What they mean by this is that the car should not be just a means of transportation. It should be the natural prolongation of your body, human machine unit. You should be part as a human. You should be part of the engine of the machine. And then you break it down in the next level, the pyramid here, the little wider tight feeling, direct feeling, speedy feeling, communicative. And if we follow that down here, we can then go to tight feeling, meaning it appears narrow, simple lines, clean lines, straight, and so on. And then the question is, which are the sensations, the physical sensations, which are triggered in this way. Only by this you can already define a lot of things: the car size, the body size, the number of seats, the engine performance in some way, but also things like the design of the cockpit. If you've ever tested this Miata car, or the MX-5 as it's called in Europe, you will realize that you're sitting very low in the car. You have very high lines, and it's kind of snug. It's kind of snug driving position, and that is on purpose, because you should be engulfed by the car. You should be part of it. Other manufacturers do know that as well. BMW, for example, adapts a similar concept. After my experience at Volvo and the gearboxes I was presenting you in the beginning of this video clip, I had the possibility to go to Japan and work for Mazda in Hiroshima for a couple of months. At that point, I learned about Kansei Engineering. That was the very starting point on my career, my interest in Kansei Engineering. So I would like to present some of the results and how we did that. So you can see the procedure Mazda was using is more or less following the Figure 5, although Figure 5 came about much later. But then the methodology they were using here. So initially we were collecting these Kansei words, we were aggregating them, finding the dimensions. We were also looking on steering wheels. There were different methods than we have today for actually finding the properties, the emotional properties. In this case, for this example here, I chose to focus on the number of spokes, 2, 3, 4, and the pad area and the color maybe. We also then collected samples of words which were of steering wheels which were representing the different properties to the users, and asked the users to rate the steering wheel on semantic differential scales. I will show you in a second. And for the evaluation, we were using quantification theory type 1, which is a fancy word for linear regression analysis with dummy coding. It's nothing very advanced, but the combination of methodology is something unique to Kansei Engineering. Here you can see an excerpt of the Kansei Engineering words. We had a lot in the beginning. We were aggregating them. I think that is the result from the second aggregation state. We could even further aggregate them, and by just looking at them, you will realize that some of them still have a meaning-wise overlap. And in the end, the theory of the semantic differential is that you should be able to describe the whole space with just 3-dimensional words. When that was done, we presented each and every one of the steering wheels to the two potential drivers. They were asked to rate the steering wheel on a visual analog scale. Initially, this cursor was in the middle, and then you were supposed to click and just move it to where you thought it would be right. You can see these scales are different than those which we use today. There's a reason to that. These are a little bit inferior than the modern scales we are using, but in principle they work the same way. And just from this data collection, we can get the um, emotional fingerprint or emotional profile, just like in the previous chapter of the fuzzy drink bottles. So some of the results were those. We got out steering wheels which both rated high for male and strict. The right would be um, perceived to be more dull than the left, which was more classic. And if the choice was between those two wheels, you would probably go for the left-hand steering wheel, not the dull one. Of course, you don't want to make the design worse. Also, we could see that the steering wheel, which was very similar, the right hand steering wheel was both were exclusive and robust, but the right hand steering wheel rated more elegant than left hand. And here you can see the difference already, that the steering wheel in principle are the same, only differences are the material of the rim. So the elegant is some type of wood decor. Now you could say, well, I could have said that before, but in fact we were looking at hundreds of different properties, and we were looking at least 20 of different dimensions, and finding out those things was quite valuable to us. In the end, we did the same thing like for the fizzy drink bottles. We could find out here that the color, the spokes and pad area broke down in this way, and we could see that from the result that the number of spokes here received a higher so-called PCC, partial correlation coefficient, then, and that that indicates that the relative importance for the spokes, number of spokes, is higher than for the actual color of the steering wheel. We could also see that 2 spokes were decreasing the rating for exclusive, while 3 spokes were increasing exclusiveness level. We could see that a silver steering wheel, meaning brushed aluminium in this case, were more or less doing nothing. Bronze, because it's around 0, a bronze steering wheel were increasing that. And this is basically the same evaluation method and the same presentation of results as we've seen in the fizzy drink bottles. Another example here comes from Komatsu. Komatsu is a manufacturer of building machines, excavators, for example, and they have been using Kansei Engineering for the exterior design, of course, and in some case also for the coloring. So imagine that you're passing by a workspace somewhere, or work area, and you see excavators, and most excavators are yellowish with black stripes or black trim. Why is that so? Not because everybody likes it. It has a warning character, and it has a very effective way of warning. So it's hardwired in your brain that yellow and black is something which can be dangerous. I mean, wasps and bees and so on use that already, so you know that's hardwired in your brain, and that's why if you see a machine like color like that, it gives you the impression, okay, it's dangerous, be careful. But Komatsu said that it's very difficult to distinguish a Komatsu machine from a Volvo or Atlas machine. So we want to have something else. We want to have a color of our own, which still maintains the warning character. And using Kansei Engineering, they came up with this color. it's a bluish green, and this bluish green is also associated to something which is not healthy. It's poisonous. It's dangerous, and it's reflecting more or less uh, the same feeling of being careful of being dangerous. So that's what Komatsu has patented, and they own this particular color. So when you next time pass by a building space and you see a machine which is greenish blue, then it must be a Komatsu. Nobody else is allowed to use this color. Other aspect they have been using Kansei in is the interior design and the steering characteristics. So here you can see a typical working position for a Komatsu machine. You see you have two joysticks, and these two joysticks of course have electric actuators in there, and they are then the inputs impulses are then treated by a computer, and from the computer it's the information is translated into a steering signal for hydraulic pumps and valves. So depending on how you choose the computer and the signals and how you put the settings of the computer, the machine can work, or the signal can be transmitted faster or slower. You can ramp it up or you can ramp it down, or anyhow you can actually set the characteristics. And Komatsu found out that by setting the characteristics in a certain way, you could give different impressions. So it could be something that of course, you want to have the machine moving fast, but if you have the machine moving or have the steer very aggressively, the driver will, or the operator will get tired very soon. There's a very high fatigue effect in there. So you have to balance that fatigue effect with the reaction of the machine, and at the same time balance it with the productivity. Kansei Engineering can help you with that and setting the reactions and of the machine towards the input signals in the right way. Another study was done in Sweden here for a company called Scandia. So if you're buying an apartment, and we had an example of how to describe apartments. This is the study which matches the initial word set up here. Usually the apartment is presented in a 2D sketch like this, you can see here on a blueprint. And sometimes when a company is building apartment blocks, they would like to sell these in advance. As a buyer, I then have the possibility to have a look on this 2D blueprint and decide, do I want to buy it or don't I want to buy it? But that's very hard for me to imagine. I don't know how the feeling is. And as you remember from the second chapter of this lecture, there are dimensions like security, like lifestyle, and so on, which I can't see from this 2D blueprint. And that might inhibit people actually from willing to wow a lot of money on that, or put a lot of money on that, as long as you can't see the ready project. So what we did was then asking ourselves, is there a possibility to present the data in a different way? So safety, privacy, lighting, comfort, lifestyle, those are aspects which I'm interested in. As I said previously here, I'm interested in how the light will be on a Sunday morning in my living room or in my sleeping room, or whatever. Will it be nice, or will it be something which disturbs me? And for that, we were using 3D tools. Firstly, we did a 3D tool where I actually could place my furniture in the flat, so I can understand that the I don't know, the wardrobe which I inherited from my grandfather still fits in my sleeping room, and so on. And then I could render a 3D walkthrough, so I could with virtual reality go through this flat. What we found out there was that although we had 3D, the impression was in some way not totally the same, or the affective impression was not totally the same as it would be in the real flat if we compared to the real flat. And we found out that in some way for the 3D experience we had to exaggerate colors a little bit to get the same impression as in the real flat. But by knowing that, we then could, if for flats which were not built yet, could exaggerate these colors a little bit and modify the presentation way, so it would actually be the same impression as the flat which would be built later on. We can see it on this picture here. This is an actual rendering from a flat which is not existing, but where the user could, in the first step, put in his furniture or her furniture, and then let the computer render it, and you could make a walkthrough in 3D. Other studies which have been done in Sweden. I've been talking about flats. That was a prototype here. I've been talking about the Toyota trucks here, and where we even had a patent. I've been talking about floor care devices. Here we had another company. This company builds laminate flooring. Laminate flooring is a very sturdy flooring, which is very resistant to bleaching, very resistant to scratching, has actually a very high durability, very environmentally friendly. The problem is the reputation is quite bad. People perceive this as second choice. In the Scandinavian countries, you would like to have real wood flooring, parquet flooring. Problem is with real parquet flooring, it is not suitable in every case. In a private flat or apartment, it would work, but if you would put it in some type of official area, it will wear down very fast, because you have just a very little layer of lacquer on it, and it will wear down very fast. So laminate flooring is much better. Also, laminate flooring includes even more wood than a normal wood flooring would do, because you have wood chips in there. But anyhow, people will perceive it as inferior. So the company came up with something what they called synchronous surfaces. So when you paint normal wood, you would see that along the grains you would have some indents, so the lacquer would be sinking in there in some way, and that's why how you can visually differentiate between this fake flooring or laminate flooring and real wood flooring. By introducing synchronous surfaces, you wouldn't be able to do that. The surface would look like a real floor. And we had samples which we presented to experts, and these experts had no possibility to tell you which was real wood and which one would be the laminate flooring. So they were really happy with doing that. As soon as you put this floor into a room, everybody could tell you this is no real wood flooring. Why is that? Because of the sound. Laminate flooring, because of its ability to withstand scratches and dents and all that one, and is much harder. And much harder means that you have a very different sound when you walk on it. It's more tapping sound. Using Kansei Engineering, we went and measured the frequencies, the sound frequencies, and found out that the frequencies of the tapping sound on laminate flooring has higher pitch, meaning making different sound. So by putting actually underneath a rubber layer, we could dampen this type out, and in the end, we even could have a sound which sounded like real wood flooring, although it wasn't. Now somebody could say, well, that's cheating. Is it or isn't it? Sometimes human beings are strange or customers are strange in terms of that they expect something, it should be like that, and wooden flooring should be like wooden flooring, but at the same time it should be very resistant, should be scratch resistant and so on, and wooden flooring can't do that. So you could also see this study as a way to give the customer the best out of two worlds, the scratch bleach resistance, at the same time the same feel and sound and feeling about natural material as you would have in wood flooring. So concluding, we will go through a couple of different companies. You can see that Kansei Engineering is being utilized by many different companies. Here we have some of the samples, but what you can see, of course, we have motor companies, more even today. We have electronic companies here. We have companies working with wardrobe, um, underwear, for example. We have companies working with perfume and body care. So you see the span of Kansei engineering applications are very wide. These companies are Japanese companies, and I chose them because they were more or less pioneers on the area. Kansei Engineering is nowadays used worldwide in many cases, but those were quite pioneering the whole the whole development of Kansei Engineering. So please let me finish with thank you very much if you were able to make it until here. If you are interested in more information or you would like to get in contact with me, you can have my mail address here. Thank you very much, and hope see you in some of my other videos.